All right, so we've got 65, 66, and 67. 65 is pretty simple. We're simplifying. It's all exponential rules. So one thing to realize with this is I'm going to collect my like terms. So the v's go with the v's and the numbers go with the numbers. So what's 2 times 4?
8.
8. Okay. And then v to the 4th times v to the 4th means I'm going to add those 4's, right? So 4 plus 4 is 8, right? So then that's v to the 8th. And then the only thing left is u to the negative 1. And so just like I asked my Algebra 1 students, and they actually knew this answer, so please know this answer. What are we going to do with the negative 1? Put it on the bottom. Yes. Love it. Okay, so we're going to just draw that line and go, hey, I'm taking this down below, right? And so this is going to be 8v to the 8 all over u to the 1. Because that negative becomes a positive when I move it down below. Right? And that's it. That's done. Okay? So now let's go on to factoring. Alright, now this is, whenever you see more than 3 pieces, we're going to do what's called factor by grouping. Right? You remember way back, midterm, first semester, right? So this is why we have this second semester. Like, not too many schools throw a midterm at their students that covers everything since the beginning of the year, right? But I think in doing this is going to make us so much more prepared for that SBAC, okay? So, now remember, factor by grouping is really easy. I'm just going to group these up. I'm going to go like this. Boom. Boom. Just like that. It's really simple. And then upside down division. Okay, this is something nobody teaches their students. Nobody teaches because what? I made it up. Right? So, but you have an opportunity to learn it and always retain it. Okay? So upside down division, it's just an easy way of saying factoring. I'm going to factor out, okay, what's common in both of these. Okay? 7. And then how many n's are common in both of them?
2.
Yeah, there's 2 n's, right? There's 2 here and 3 here. So that means there's 2 in both of them. Does that make sense? And so we're going to factor that out. And so if I take a 7 out of the 14, I divide it out, right? Then it's, what is 14 divided by 7?
7.
2. Right? And then, now, but like what you were doing, subtraction,
Yeah.
that's what we do with the exponents, right? So 2 minus 3 is?
Negative 1.
2, oh yeah, my bad. 3 minus 2
Is 1.
is 1. I said it backwards. Okay? So we got 1 left, right? And then the same thing here. How many times does 7 go into 7? Once. That's why there's still a 1 there, right? And if I take 2 away from 2, I get 0, right? So we don't need any n's. Does that make sense?
Yeah.
Okay? Same thing here. What goes into 2 and 4?
2.
2. How many times?
2.
2 and
Plus 1.
1. Good. Now look at this. This is beautiful. Okay? We have 7n squared times 2n plus 1 plus, that plus comes down. This plus comes down. Okay? 2n plus 1 times 2. What's common? What's common here? 2n plus 1. Yeah. And so I'm going to pull that out. 2n plus 1. Right? And so what's left here if I take the 2n plus 1 out? 7n squared. And what's left over here? 2. Good. So plus 2. And so we're left with 7n squared plus 2 times 2n plus 1. I love this board so much more than those boards. It just gives me that little extra room, I think. I don't know why I like this so much more. Doesn't that seem like it gives you more room?
Yeah. Oh, it is
Right?
bigger. Just kidding.
But what's funny is it's really not that much bigger than that. It's kind of like when you go up and you're golfing, right? And then all you see are trees and trees. And you're like, well, I got to keep it in between the trees. And whack, you hit the tree every single time, right? But yeah, when you got nothing in front of you, it goes straight down the fairway. It's like beauty. So this was straight down the fairway. Didn't have to worry about nothing. All right, so this next one, is this more than 2 pieces? Right? It's more than 2 pieces, right? It's more than 3 pieces. I'm sorry, it's more than 3 pieces. So we got to factor by grouping here. So we're going to group it up. But here's the thing. And so I'm going to rewrite this so that you can see it, because I got plenty of space. I feel like I got all the space in the world here. Okay? So I'm going to just take my time and write it out. Right? And so that's going to be one group. A group of 2, right? And then I'm always going to be plus another group. Okay? And when I do that, I have to put this minus 16x to the 4th in there. Okay? Oh, give me some more room. I got plenty. So plus 64x squared. And that equals 0. Okay. So, now what I do, since I split them up, notice the trick there? This plus, I put here, I just basically put a plus. I said plus a minus. And then that way, I've got my minuses in here and it's always plus. Okay? Plus the rest. Okay, that's huge. Now, what do I do? What do I do when I factor by grouping? What do I do? What's the step that you guys know that nobody else knows how to do? Because I made it up.
Upside down division.
That's right, baby. All right, so then we go to upside down division. Right? Upside down division. And we're going to worry about what goes in to x to the 8th and x to the 6th. What? X to the 6th. See, that wasn't too hard, right? And then if I take that out, how many x's are left? 2, good. So this is x squared, right? And then what's left here?
Negative 4.
Negative 4. Very good. Very good. Okay? All right, now let's do it over here. Do it over here. What goes into 16 and 64? 9? No? What goes into 16 and goes into 64? 8.
Oh, 4.
4. Yep. Bigger number though.
16.
16. Alright? 16. Now we could keep doing it. Don't get me wrong. We could do the 2, we could do the 4, and then you would do it again. Right? Let's just give you a little quick example. Preview. What if I would have said 8? Okay, then this would have been a negative 2x, right? To the 4th, plus 8x squared. And then we would have said, oh, well, 2 goes into that, right? And you could do that. That's totally legal. That's why I like using upside down division. Because it allows you to do your baby steps if you need them. If you need them, okay? Right now, I'm kind of forcing you to do a little bit more than baby steps. Use your big boy pants, big girl pants, right? We're going to pull them up, you know? And we're going to use a 16, right? But beyond the 16, right? Because this says plus minus, I want this one to say plus minus. But right now it says minus plus. How do I change that? Yes, taking out negative. Okay? All right. It's all good. So we take out a negative. Right? And what that's going to do is going to change this sign to a positive and change this sign to a negative. All right? We have one more step. We got to take out all those x's. How many x's can we take out? 2. Right? That's the most we can take out. It's the least amount, right? There's 2 here, there's 4 here. So we're going to take out 2. All right? So when we do that, how many times does negative 16 go into negative 16? Once, right? And then how many times? 2 from 4. 2. So that leaves an x squared, right? And then how many times does 16 go into 64? 4, right? And then a negative and a positive make a negative, right? So that's going to be 4, and then that's it, right? Because we took the x out, the x squared out. Does that make sense so far? So let's rewrite it. And right now this pen, goodness, how did I miss that? How did I miss that? All right, well, let me grab this pen. This pen's better. Well, you know.
It went all the way back to where you were.
Went all the way back here? Oh, nice. See, it refed me.
So you better make
It was like, hey, Dan, we got to put the right cap on. That was God's way of saying, we want to do the right cap on, and then we got you all day. What? What? All right, so all day. All right, so then I'm going to rewrite this. So I've got x to the 6th times x squared minus 4 plus x squared minus 4 times negative 16x squared, right? Equals 0. Okay. All right. Now, what's common? Yeah. The x squared minus 4 is common. So if I pull that out, what's left?
X squared.
X to the
6.
6.
Oh, the x to the 6.
Right? Plus how much?
Negative 16.
Negative 16 x squared, right? So let's just clean that up. Let's rewrite it. So I got x squared minus 4, right? Times x to the 6th minus 16. Because that's a negative, right? Sorry. And a negative and a positive make a negative, right? We good? Okay, and that's x squared. And that equals to 0. All right. We're almost there, people. We're almost there. Now here's the thing. We got our big boy and big girl pants on, right? Oh, good to go. Okay? And we noticed something. We noticed that this is a square. And this is a difference. Do you notice that 4 is a square also? Right? So this is a square, right? And this is a square also. This is a square of x's, right? X squared, right? What's this a square of? What times what is 4?
2.
2. So it's a square of 2's. And it's a difference of squares. Right? And so we're going to write it with the conjugate. Remember? This goes with the conjugate. You remember what a conjugate is?
No.
Who remembers? Conjugate. If I write x minus 2, what's the conjugate? 2. No. Williams. As soon as I can. As soon as I can. I'm right in the middle of teaching. Okay. Sorry, guys. Just don't do it. Alright, so. Alright, so. The conjugate. What's the conjugate?
The negative sign?
Yes! And so, instead of it being negative, it's going to be?
Positive.
That's it. That's all the conjugate is. It's the opposite sign. If it was positive, this one would be negative. That's all. If it was plus, it would be minus. If it was minus, then it's going to be plus. That's the only difference. That's the conjugate. And that's difference of squares. Now, we could solve that using factoring, right? Remember our 5-step method? Right? But then we would have to say x squared plus 0x minus 4, and then two things that multiply to be 4 but subtract to be 0. So two things that multiply to be 4 and subtract to be 0. Very good. 2 and 2, right? Okay. And then you'd have x, and this would come down plus, and this tells me it's different. So those are, that's another way of doing it, right? Or you use your conjugate. Difference of squares, right? Look at this. Can we actually take something out? Can we still do upside down division here?
Yes.
What can we pull out? X squared. Good. You can say it. It's good. I like it. All right, so x squared. And if I pull out an x squared, how many are left?
4.
X to the 4th. Right? Minus 16, right? And then we pulled out an x squared. Right on. But check this out, peeps. Is this a square? Can two things that are exactly alike multiply to become x to the 4th? So think about this. What is x squared times x squared? X to the 4th, right? So it's a perfect square of x squared, right? And then what's the square of 16? What's a perfect square? What multiplies to be 16? 4 times 4, right? And it's a difference, right? It's a difference of two squares, right? So we got x squared minus 4, right? What's the conjugate? X squared plus 4. Okay? And then that equals, times x squared. And then we'll bring this down. X plus 2 and x minus 2. Okay. Hey, can we factor this? Is this perfect square?
Yeah.
Yeah, of what? 4. Not 4. 2. Yeah, it's back to this, right? Doesn't it look just like that? Right? So it's again, this is a square. This is a square. This is of x. And this is of 2. And then we just have, what's the conjugate?
Plus 2.
Plus 2. X plus 2. Then we write all that other stuff. X squared plus 4. X squared equals 0. X plus 2. X minus 2. Is this a perfect square? Is this a perfect square? Yes. Is this a minus? No. Okay, we can't do that one. Okay? Because remember, it only works for a difference of two squares. Right? So a sum of two squares doesn't work. Okay? So, what's beautiful here is now we get to solve. Now, here's the thing. When you have a factor like this is huge, by the way, isn't it? It's a lot, right? But if this is 0, does it matter what all this is? If this is 0, what's 0 times blah, 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 blah? 0, right? What if this were 0? What's 0 times blah, 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 blah? 0. If this were 0, what's 0 times blah, 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 blah? 0, right? So, for each of these, we want to solve for 0. Okay? We want to make them 0. Alright, so x, what does x have to be for that to be 0? How am I going to make this equal to 0? What does x have to be if you're going to subtract 2 from it to get 0? 2. Alright? So if x is 2, 2 minus 2 is 0, right? So there's an answer. All right. What plus 2 is 0? Negative 2. All right. What minus 2 is 0? 2. Okay. What plus 2 is 0? Negative 2. Okay. Some of these are coming up twice, right? So we only have to write those answers down once. But I just wanted to show you, because, this might have been different, right? It might have been x plus 3x minus 3, because it was 9 or something like that. Anything could happen, right? I just want to show you. You want to do it for every single one. All right. Now it's getting a little harder. Let's skip this one, right? Because that one's, well, is that possible in the real world? Right? Because it has to be a negative number, right? So, for what positive number plus 4 is 0? What positive number plus 4 is 0? Because this says x squared. And x squared will always be a positive number, right? Because negative times negative is a positive, right? So what positive number is there that could be an answer? There is no one, right? There's no solution here. There's no solution there, right? Well, I'm going to show you why in a minute, okay? But
I wish you made more space on these packets.
oh, me too. Me too. Unfortunately, the packets only allowed me to give you 15 pages. In fact, they wanted to do it on 10, but they couldn't fit it, so they made 15. I couldn't find a way to make this. Usually I would have put this as like 25 pages. Then you would have had a lot more space. But the good part is you can do this in your notebook. That's where I highly suggest you do these problems, is in your notebook. Okay? All right, so then I got to think, okay, what squared is 0? 0. Okay. So 0 squared is 0, okay? All right. So now we have all these answers. We don't have an answer for this one. No real solution, right? No real solution. Let's ask ourselves why. X squared plus 4 equals 0. Let's solve that. How do I solve that? Minus 4. Minus 4. X squared equals negative 4. Okay, what do I do to solve for x? Right? Square root. Right? Square root. So x equals the square root of negative 4. What's the square root of a negative 1? I. Right? I square root 4. What's the square root of 4? 2. So x is equal to 2i. So there is a solution, it's just not real. Okay? Okay? There's a solution, it's just not real. So now this is really 2i. And that's what I wanted to point out. Now, what numbers are the same, which numbers are different? So, how many answers are there? X is equal to what? Let's start with 2i. What else? What's the lowest number? Negative 2. 0.